Hi, I hope you are fine and doing well in your organic classes. Today we are addressing the last segment of our course concerned, which is about heterocyclic compound. Today we will focus on different aspects of heterocyclic compound. We will study its introduction, what exactly heterocyclic compound are, what are their significance in organic chemistry, how they are synthesized, what are their important reactions, and their pharmacological significance at the end. So let us focus first on what are heterocyclic compound. When we talk of heterocyclic compound, basically we refer to a cyclic compound which consists of two or more than two different type of atom. So far we have studied simple cyclic compound which consists of only one kind of atom, such as carbon atom. So such cyclic compound which are made up of just only one type of carbon or atoms, so they are known as isocyclic compound. When the cyclic compound is made up of just carbon atoms, so the cyclic compound will be regarded as carbocyclic. So cyclic compound are basically divided into two classes, isocyclic and heterocyclic. Isocyclic can be carbocyclic. Again, carbocyclic can be divided into aliphatic and aromatic. Just take a simple example of cyclohexane, which is an example of aliphatic carbocyclic compound. And as far as benzene is concerned, so this is aromatic carbocyclic compound. Next category is of heterocyclic, which is the focus of our lecture today. Can be divided into inorganic heterocyclic compound and organic heterocyclic compound. So we have already realized distinction between what are organic compound and what are inorganic compound. Basically inorganic compound are made up of atom other than carbon and hydrogen. So all such compound are known as carbocyclic or inorganic heterocyclic compound, which consists of atom other than just, we have given an example of borazine, which is known as inorganic benzene. So the 6 member ring consists of boron and nitrogen atoms. So such type of heterocyclic compound are known as inorganic heterocyclic compound. And as far as the organic heterocyclic compound are concerned, they can be, again, just like a carbocyclic compound, can be divided into aliphatic and aromatic. So aliphatic they are just unsaturated, or they can be saturated as well. So there is a simple distinction between aliphatic and aromatic. In aliphatic compound there is no aromaticity, but as far as aromatic heterocyclic compound are concerned, so they consist of aromaticity, or they demonstrate the characteristic feature of aromaticity, or they are aromatic in character. So here we have an example of TH8 tetrahydrofuran as example of aliphatic hydrocarbon, piperidine and morpholine. These all are aliphatic heterocyclic. But as far as the aromatic heterocyclic compound are concerned, they are very important, especially 5 and 6 member ring compound are very important in organic chemistry. Basically heterocyclic chemistry is a branch of organic chemistry that addresses large category of compound. So 5 and 6 member heterocyclic compound are very common in organic chemistry. Again, these aromatic heterocyclic compounds such as pyrrole, thiophene and pyridine, they are monocyclic. They can also be a bicyclic as well. Just take an example of quinoline, which consists of 2 rings. So such heterocyclic compound are known as a bicyclic heterocyclic compound. Another important category of heterocyclic compound is alkalides, which is a very diverse class of naturally occurring heterocyclic compound. Alkalides are basically basic nitrogenous compound, in which one of the identity of alkalide is that they have a presence of basic nitrogen atom as a characteristic feature. So we have given some important example of alkalides. These all are heterocyclic in one or another way, such as morphine, heroin, quinine, atropine, nicotine, cocaine, and dopamine. So these are all naturally occurring heterocyclic compounds. This dopamine is a neurotransmitter. Okay. So all these are an example of heterocyclic compound which occur in alkaloid, or it belong to alkaloid family. So these are simple example of alkaloid and simple distinction between what exactly heterocyclic compound, how they are different from naturally occurring simple carbocyclic or isocyclic compounds. Here as far as significance of heterocyclic compound are concerned, so they play a very diverse role in organic chemistry. They act as a solvent, such as we have used THF, tetrahydrofuran, especially in synthesis of Grignard reagent when we reacted alkyl halide with magnesium, turning in the presence of some inner solvent, and at that time the inner solvent was THF. So they play an important role as a solvent in organic chemistry. As far as we use them as a catalyst, oxidizing or reducing agent as well. Just take an example of PCC, pyridinium chlorochromate, which we used as a strong mild oxidizing agent in oxidation of alcohol to aldehyde, rather than oxidizing the final product to carboxylic acid. So it is a mild and selective oxidizing agent. It can be prepared by chromium trioxide reacting with pyridine reacting with HCl, and chromium trioxide give rise to formation of PCC. So this is PCC, pyridinium chlorochromate. So here we have used it as a oxidizing agent. Further, pyridine can also be used as an acid scavenger agent as well. Acid scavenging, it means that in some reaction there are chances of acid formation. So if the acid is left intact in the reaction medium, it will interfere with the product and it will further compel the product to react, so we will not get a desired product. So we require some specific agent in order to control or scavenge or quit the acid which has formed in a product. So pyridine play an important role in order to capture the formation of acid in product. That's why we call it pyridine as a acid scavenger agent. Just take an example of here, alcohols react with this compound, we use pyridine. For example, type of condensation reaction in which HCl molecule eliminates. So this HCl molecule is finally captured by the pyridine, and ultimately we give a product without any interference of acid. Moreover, alkaloid or heterocyclic compound also play an important role as a pharmacologically active compound. They act as a tranquilizer or they act as a barbiturates. Tranquilizer are basically medicines which are used to make tranquility. Tranquility means to relieve or to soothe or to make you relax. For example, different people are suffering from depression, they have various sort of mental or physical ailments. So in order to relieve those ailments, we usually prescribe tranquilizer, which are usually heterocyclic compound for such patients. They can also be used as a barbiturate. Barbiturate is class of heterocyclic compound. They can act as a they play out a role of soporific agent, sedative agent, or hypnotic agent. Soporific basically sleep causing. For example, all sleeping pill can use this heterocyclic compound as a soporific. So patient take these pills in order to induce sleeping in them. They are sedative, relieve, or relax, for relaxing again, for giving rest. So Hypnotic are those drugs especially which induce rest or it make a person feel relaxed, sedative and soporific. So this is simple about a general introduction of heterocyclic. So heterocyclic compounds are very important in organic chemistry and they play a very diverse role. We have just briefly defined its introduction. We classify different type of heterocyclic compound. We also focus some light on their importance in organic chemistry. Okay, thank you for watching video.